What's up, everyone? Welcome back to the channel. Have you ever wondered how Google can find similar images when you upload a photo, or how Shazam identifies songs in seconds? Today, we're diving deep into one of the most fascinating applications of AI, multimedia search using vector databases. From reverse image search to finding that perfect audio clip, we'll explore how vectors are revolutionizing the way we search through images, audio, and video content. And yes, we'll build some cool examples together. So grab your coffee, hit that like button, and let's unlock the magic of multimedia vector search. Let's start with a simple question. How do you currently search for images or videos? Most of us rely on file names, tags, or descriptions, right? But here's the problem. What if I show you this beautiful sunset image and ask you to find similar ones? You'd probably search for sunset, orange sky, or beach. But what if the file wasn't tagged properly? What if it was named img_2847.jpg? Traditional search completely fails here. This is where multimedia content gets tricky. Images, audio, and videos are unstructured data. Their true content, the colors, shapes, sounds, emotions, can't be captured by simple text descriptions. That's exactly why we need vector search, a way to understand and search multimedia content based on what it actually contains, not just what someone wrote about it. So, what exactly is a vector? Think of it as a digital fingerprint for any piece of media. A vector is essentially a list of numbers, but not just any numbers. These numbers represent the features and characteristics of your media file in a mathematical space. For example, when we process this cat image through a neural network, we get something like this. Notice how similar the cat and dog vectors are? That's because they share common features: fur, four legs, ears. This similarity in vector space translates to visual similarity. Now, let's see how different types of media are converted into these magical vectors. Images. For images, we use convolutional neural networks, or vision transformers. The network analyzes colors, shapes, textures, and objects, then compresses all this information into a dense vector. Audio. For audio files, we first convert sound waves into spectrograms, visual representations of frequencies over time. Then models like VGG-ish or wave-to-vec analyze these patterns to create embeddings that capture pitch, tone, rhythm, and timbre. Video. Videos are the most complex. We process them frame by frame, sometimes extracting keyframes or analyzing short clips. We use spatial temporal models that understand both what's happening visually and how it changes over time. Once we have all these vectors, we need somewhere to store and search them efficiently. Enter vector databases. Popular options include Pinecone, Milvus, Waviate, and Face. These databases are optimized for something called nearest neighbor search. Here's how it works. When you submit a query, say an image, it gets converted to a vector. The database then finds the vectors that are closest to your query vector in this high-dimensional space. We measure closeness using metrics like cosine similarity or Euclidean distance. The closer the vectors, the more similar the content. Here's where things get really exciting. Cross-modal search. This means you can search across different types of media. Imagine describing a scene with text and finding matching images, or humming a tune and finding similar music videos. This is possible when we embed different media types into a shared vector space. Models like Clip from OpenAI can understand both images and text in the same vector space. Watch this. First, we'll create an image database, extract embeddings, and then build a search interface. This technology is everywhere. Let me show you some amazing real-world applications. E-commerce. Ever used Google Lens to find where to buy something you photographed? That's vector search in action. Content creation. Stock photo websites use this to help you find the perfect image. Upload your concept, get thousands of similar options. Security and surveillance. Law enforcement uses facial recognition and video analysis to identify suspects across multiple cameras. Music discovery. Spotify's recommendation system uses audio fingerprinting to suggest songs with similar vibes, not just genres. Of course, it's not all smooth sailing. Let's talk about the main challenges and how to overcome them. Scale problem. When you have millions of vectors, exact search becomes too slow. That's why we use approximate nearest neighbor algorithms like LSH, IVF, or HNSW. Quality issues. Your search is only as good as your embeddings. Domain-specific fine-tuning often makes a huge difference. Infrastructure costs. Vector databases can be expensive to run at scale. Consider hybrid approaches and efficient indexing strategies. Ready for some advanced tricks? Let's explore some cutting-edge techniques. Multi-vector search. Instead of one vector per image, use multiple vectors for different regions or aspects. Temporal embeddings. For videos, embed temporal information to understand sequences and actions. Weighted search. Combine multiple query types with different weights, 70% visual similarity, 30% color matching. What's coming next in multimedia search? The future is incredibly exciting. Unified multimodal search. Imagine searching with a combination of text, image, audio, and video all at once. Real-time processing. GPU and TPU acceleration are making real-time video analysis possible for live streams. Conversational search. AI assistants that understand context, like find me videos like the one we discussed yesterday, but with better lighting. Privacy-preserving search. Federated learning allows searching without exposing your private data. And that's a wrap on our deep dive into multimedia vector search. We've covered everything from basic concepts to building your own search engine. If you want to see more AI tutorials like this, smash that subscribe button and ring the notification bell. Drop a comment if you have questions or want to see specific topics covered. What would you build with multimedia search? A Pinterest clone? A music discovery app? Let me know in the comments. Thanks for watching, and I'll see you in the next video where we'll explore transformer architectures in computer vision. Until then, keep coding.